everybody.
Hi, everybody. Always really fun to be the first speaker after lunch. I'm sorry to drag you away from your food, but I hope this is enjoyable. So today I'm going to be talking about smart contracts and the blockchain as court. And I did previously teach about the history of the internet and the intersection between law and technology. So we'll go a little bit into the history of the internet and law. So back in 1996, the first major law in the US to regulate the internet was passed. It was called the Communications Decency Act. And there was a huge uproar. Yeah, okay, those of you that know. There was a huge uproar, especially from the internet freedom communities, the EFF and the like, in part because this was an attempt to regulate free speech. One of the aspects of the law was that it was going to make it a potentially criminal act to say indecent words to people under 18 on the internet. So as we know, the 7 dirty words, all of that just wasn't necessarily going to fly. So there was a big protest. The EFF led what was called a Blue Ribbon Campaign, and a lot of internet activists spoke out against this law as they saw as an attempt to regulate the internet and shut down free speech. Along came somebody named John Perry Barlow. How many people have heard of him? John Perry Barlow? He's one of the founders of the EFF, Electronic Frontier Foundation, a digital civil liberties organization, and he was a lyricist for the Grateful Dead. So he went from being in the music world to being in the internet world. And he wrote this famous piece back in '96, where he basically posits that the internet cannot be regulated. It is a new place with a new community, and it does not subscribe to the laws of the outside world. Here he says, you have no sovereignty where we gather, we have no elective government, and we're not likely to have one. You do not know us, and you do not know our world. Cyberspace does not lie within your borders. He says that your legal concepts don't matter here. You're terrified of us. We're a different culture, and we will create a civilization of the mind, and that it'll be a better one than those that governments have made. And this was on February 8th in 1996. Fast forward to 1999. Along comes a law professor named Lawrence Lessig. How many people here know about Lawrence Lessig? So I actually found the Japanese translation of the book here. This is the cover. He releases a book called Code and Other Laws of Cyberspace. And the argument that Larry Lessig made was effectively that Barlow was wrong, that actually the internet can be regulated and it will be regulated, but actually the way in which it's regulated may differ from the way that past things were regulated. So for example, in his book, he calls this, by the way, the pathetic dot. I don't know if it's pathetic because it has a lot of different things pushing on it, but there are a variety of different forces that can regulate the internet, including market and norms, law, or what he calls his East Coast Code. So basically, the laws we know it today, and then architecture. And here he makes the argument that code actually can be a form of law, that if something is written into code, it can regulate. And unlike the architecture in the real world that might be determined by, say, physics or bridges, the humans. So it's a different world when this code can regulate. Let's fast forward again to 2016. There was a really interesting experiment on the Ethereum blockchain called the DAO. How many people here heard about this, the DAO? So for those that had not, the creators of this smart contract, if you will, had really interesting marketing, and they were really going all out, and they were saying, this is revolutionary. It's autonomous, it's rewarding, and it's code. And all the code is built into the contract. And what this DAO, and they called themselves the DAO, effectively was a means for people to buy tokens whereby they would invest into a crowd-funded venture fund of sorts, where the various members of this crowd-funded venture fund would then vote on proposals, and then those proposals would get funded. And there were all sorts of complexities that are beyond the scope of what we're discussing today, but it was a highly complex contract. So the creators of the DAO said things like, this is operating solely with the steadfast iron will of unstoppable code. And And so, for example, here is right before they ended their crowd sale where they raised money that was all within this smart contract, where over 100 million US dollars worth had been raised. Here's after their sale finished. It was started in April, I think ended it at the end of May 28th, where they had raised 165 million US dollars worth of Ether that was then put in here. The exchange rate depended upon exactly how much was in this smart contract. So you had the founder of the company that created the DAO, it was called Slockit, saying things like, holding so much energy, the colossus of the DAO is able to withstand all threats. Famous last words. Can you guess what happened next? So here's a slide from a friend and colleague over at Cornell. His name is Professor Eamon Gunn-Searer. He gave a great post-mortem after the DAO, in fact, had been hacked, where he talks about it was either 50, 60, or 70 million that was actually taken from the DAO, depending upon the exchange rate of the day. Where an attacker came in and was able to use what was called a re-entrancy bug and do all sorts of things. There were all these child DAOs where you could create sub-DAOs and basically was able to vote on those and effectively attack those too. So there were a lot of people in the midst of all this that were saying this is a huge milestone, for crowdfunding, and this is the largest crowdfunding project ever, and it was, over $150 million. And, people thought it was going to make history. And actually, this did make history. It just, the Ethereum community came together. They decided to fork their blockchain to return the funds that were stolen. There was another coin that then came out of this called Ethereum Classic. So the blockchain split, and there are now two currencies, one of which, in which the attacker kept the funds, and the other one the attacker did not. The Ethereum blockchain is worth more, and the token is worth more, but they're both going strong. And here's a really interesting example of code potentially being law. So within the terms of the DAO, the creators effectively said, well, it's the contract that governs, and everything that is embedded in this contract is what, is going to effectively be, what people abide by. But what happens in a world where, there are bugs in this code? Is code still law? And if you ask me, the answer is, it depends, and that's by the way. But when it comes to very large thefts, and when you have a contract where the intent of the contract was for people to not have their funds stolen, courts typically look at things like intent. But if it's like, I had $100 stolen, well, are you really going to go to a court because you had $100 stolen? Because actually it would cost far more to go to this court. So in many cases, we're in the world in which we're figuring this out right now. So let's rewind a little bit to the year 2015. The Lightning Network. This is what I got involved with. My colleagues, Joseph Poon and Taj Dryja, wrote this really cool paper about Lightning. And what Lightning, at its fundamental level, it's a smart contract system based on top of Bitcoin. This is a fun meme by my friend Preston Byrne, who really loves marmots. And what it effectively does is it uses the Bitcoin blockchain as a dispute resolution mechanism, and you're able to defer the broadcasting of transactions, and then when you want to go to the blockchain, it can effectively be the court. So here's a meta slide here. This is me giving a talk about Lightning, and now I have a tweet, and I'm giving a talk about the tweet. So on Lightning, what we have is, it's a form of smart contracts. It's a form of code as law, because the blockchain is the judge, it's the court, and it's the arbiter. And there's a 1 or a 0 outcome. So it's different than a human judge who might actually, make a determination and look at evidence. But in this case, it is predetermined what is going to happen, and then the blockchain can make that determination. So for those of you that, may not be as familiar with Lightning, very briefly, I'll go into how it works. So you have two participants, Alice and Bob, and they put a 2 out of 2 multi-signature entry onto the blockchain. They can each put, say, in this case, $10 worth of Bitcoin in there to have a $20 2 out of 2 entry in the blockchain. So this creates what is called a payment channel. And then they can update the state between each other, exchanging digital signatures. So then their balance it's a local consensus. So as opposed to the blockchain where everybody knows what's happening at every time, Lightning allows people to locally know what's happening and then later defer to the blockchain and trust that the blockchain is going to adjudicate correctly. So if Alice and Bob want to close and settle out the transaction, they can then go to the blockchain. They have cryptographic proof of what the latest transaction is, and the blockchain will enforce that. So if I were just, if Alice and Bob are the only 2 people transacting, that's not all that exciting because how often do you pay, one person repeatedly? So what's so exciting about Lightning is it enables you to have peer-to-peer payments via intermediaries. So you can have a variety of linked payment channels, and then Alice here can get all the way to Aaron. And unlike, say, traditional correspondent banking, with Lightning you don't have to rely on trust. Cryptographically, the intermediaries cannot steal your funds. They can only forward it. They can only receive it if and only if they've already forwarded the transaction. So this is a new type of transacting where the intermediary does not have to be trusted. And then Lightning, what we're building for right now is on the Bitcoin blockchain, but it can also work on other blockchains, such as an equity chain, an asset chain, other digital currencies, and things of the like. And it also can enable trustless exchanging between them. As long as your intermediary has liquidity on both chains, you don't have to trust that intermediary. So really the 21 million Bitcoin question is, how can we bring secure, usable smart contracts to the world? And this is something that we're all working on. With Lightning, part of it is that we're building this as a layer 2 protocol. It's a second layer above Bitcoin's blockchain. You don't have the complexity in the lower level protocol itself. Right now, we are testing on Bitcoin's test network. So we're not using real money. We're awaiting a change called segregated witness that, fingers crossed, will be integrated into the Bitcoin protocol within the next few months. We also, in the early days, will test it and send very small values, send less than a cent. By the way, one of the great things about Lightning is that it can enable sending tiny amounts of value with extremely low fees at very high volume and near instantly, which is very exciting because you've never been able to do this kind of thing before. So you can check out on GitHub. We have our code online. It's all open source. The protocol is available, github.com/Lightning Network. And usability is something I'm very passionate about. It's a really important aspect of all of this. And we are working on an app in the early days of Lightning that works on Bitcoin's testnet. So you can use this to send test Bitcoin. By the way, some of our team members they're really rich and like test Bitcoin. But unfortunately, it's not worth all that much. So we're building this app for Lightning, and we'll be building for mobile as well. And this is a desktop app. And in the end, as we've gone through the history of code as law, now we're finally seeing this live out today in terms of the possibilities of smart contracts. Our goal is to enable the blockchain to be a global decentralized judge. But this judge, cannot be bribed. There will not be, say, subjective opinions, but it will all be programmed in a way that's safe and secure. And our goal is to power the world's financial transactions with Lightning and bring smart contracts to the masses in ways that are usable and secure. Check out lightning.network or twitter.com/lightning. Thank you.
Thank you, Elizabeth. That's terrific. So we learned a little bit of somebody who wants to decentralize maybe the law of the internet in a way that cannot be bribed. We have another speaker here. When he was under 30 years of age, he was declared within 30 notable people by a magazine called Forbes. He was also the president of the Princeton Entrepreneurial Society Club during his regime. He is now the founder of Blockstack Labs, which is working to build a decentralized internet. So we are very glad to have Ryan Shea join us on stage. Thank you, Ryan.
Thank you. Hi, everyone. Thank you. Oh, this is the wrong slide. Thank you for having me. Okay, can we start from the beginning? Fostering innovation and economic inclusion. Do I have a clicker? Oh, thank you. It's all right, thank you. Here's a little bit about me that you already know. And if you would like to tweet about this presentation, the internet started out as a decentralized system. But one of the problems is that over time it became more and more centralized. Companies like Facebook and Google and Amazon started to build extremely large. So a few large companies actually make all the money. Platforms actually lock in the users and developers, and data custodianship actually leads to massive breaches. But with decentralization, we can actually reverse some of the trends of centralization that we've seen as in economic inclusion and independence, and then information security, right? So in terms of innovation, anyone can participate. Any developer can build any application that they want. In terms of inclusion, the barriers to entry for building and distributing software are reduced. So there's a lot more software types of software that are available for users, and that increases options, that increases savings for the users. The users win. In terms of independence, that means that developers are not tied to certain platforms, and the users are not tied to specific pieces of software. And in terms of information security, that means that that users can actually keep data with them and information together, right? And so we have a few notable decentralized applications that we can take a look at. One is email, another is Bittorrent, and another one is Bitcoin. So email is actually very, one of the earliest uses of the internet. And many different pieces of software. They can use Gmail, they can use Outlook, you can use clients and mobile and desktop and any device. And they all speak the same protocols. And so this decentralized network enables a large amount of innovation and enables a large amount of inclusion. And it's important because developers and users down to any single provider, right? The second one is Bittorrent. And with Bittorrent, it's a content distribution system. And there are some illicit uses, and there's also some very legitimate uses. And Bittorrent itself, there's many different pieces of software that you could actually use to interact with the network, just like with email. And again, the same theme applies. You can use whatever software you'd like, and then you can participate. And anyone can build a new client to work on top of the Bittorrent protocol. And then the third one is Bitcoin, which comes back to 2009. And Bitcoin, again, you can use whatever piece of software that you'd like to interact on the network, whether it's mobile clients, desktop clients. There are dozens and dozens of different clients and dozens of different software projects that developers are pushing forward to allow you. So this is all great, but one of the problems is that decentralized applications are actually hard to build. So there's increased complexity, there's increased security concerns, and there's increased scalability concerns. But with Blockstack, we're actually making decentralized applications easy to build. So with traditional applications, you have servers to maintain, you have databases to maintain. But with Blockstack, you actually just publish code. And you can use the user as the backend to get and put data backwards, and the data gets synced up to their cloud storage providers and encrypted. With traditional applications, you have identity management systems to build out. So we can actually get a little more concrete in how Blockstack makes building these decentralized applications easy. So we provide a library called Blockstack.js. You can build a single-page web application like you normally would, right? With an HTML file, JavaScript files, and CSS files. And instead of calling a traditional API to interact with your server and database, you can actually issue calls to the user's data store. So first you can authenticate the user, right? So in this photos, right? And then the next thing you can do is, let's say you have a photo uploading window, you can then put data back with the user. And any application that speaks this same photo protocol can get the photos from the other photo application that the user is using, and they can actually put photos back for all the other photo applications to consume. So the important thing now here is that the user is independent, is actually not tied down to any particular software provider for managing their photos. As long as they speak the same language, they can use any client they want, just like they can use any client with email. So it's not the same as using a Facebook or an Instagram to manage your photos. Your data is now yours, and you're in control. So Blockstack handles the complexity here. We have storage, authentication, identity, and naming. And it all runs on top of blockchain technology. Actually is the largest protocol across any open blockchain, including Bitcoin. And our community is growing very fast. So we have about 2,000 people in our Slack community, and we have 2,000 people in our meetup groups around the world, from New York to San Francisco to China. Can be on top of. The other thing is that we do not reinvent the wheel where we don't have to. So we reuse existing blockchains, and we also reuse existing cloud storage providers. So users can bring their own cloud storage providers, and they can have multiple. And the data is synchronized and encrypted with them. So it provides a layer on top of these cloud storage providers to commoditize them, just like it provides a layer for authentication. The next thing that we're actually coming out with is the Blockstack browser. And this is very exciting because it is a way for consumers and developers to experience this new Blockstack-enabled internet, where applications can be built really easily in a decentralized way. And the developers actually use this browser to debug and build their applications, and then the consumers can come in and use them. And there's a couple key differences with the Blockstack browser from normal browsers. One is that it uses Blockstack's domain name system, which is a decentralized domain name system. There's no ICANN, there's no individual companies that are running the TLDs, right? It's very decentralized. And the second key component is that providers, and then you can authenticate with an application, and the app gets data from you and puts data back to you, and then syncs it up to your native applications. Easy, where the UI components live on the device, but that still uses APIs. So there's still lots of code and lots of. It's completely on the device, completely decentralized and peer-to-peer. And the UI components live on your device, the data lives on your device, the code lives on your device. And this is a new way to actually deploy and discover applications. So we can go through a few different case studies of decentralized applications so you can kind of get a feel for what the new capabilities that these decentralized applications is. A secure software distribution application, right? And this is an application where developers can publish their software, they can sign it with their identities on Blockstack, you can sign the software package, and then when you people, and then you can actually audit the way to ensure that you are in fact using the right software. The second, nobody runs the vote. You can have an online community come together, and they all they sign their votes, and they distribute their votes in a peer-to-peer fashion, and then each local client votes on their own. And then the user can actually audit the vote and make sure that the votes were tallied up correctly. And you want to make sure that it can't be censored and no one will be able to figure out who you are, right? So this is actually a way to provide a model for this type of funding for journalism that people really want to exist. So I'll close out by revisiting the benefits of decentralized applications, right? So it's innovation, it's inclusion, it's independence to function properly. All of us.
Thanks stack in the law, and a glimpse of a decentralized future that includes more folks in a better way. And now I think that sort of trajectory is going to be our next speaker, who is someone whose personal research interests are aligned with cryptography and privacy and fairness, voting systems, personal data. She's a member of the Science Council of Japan, and today she's a senior engineer at NEC, where I'm very pleased to introduce Kazue Sako.
Okay, thank you. It's nice here. So thank you for having me here, and thank you for the nice introduction. So my name is Kazue Sako, and I work for a company in Japan called NEC. Let's see if this works. How do I do this? Okay, good. I have a slide that gives my introduction, but this is on the web page again. But there's one thing I forgot to write down, which is about the workshop on real-life cryptographic protocols and standard and 20 located with financial cryptography. And I think this workshop is very relevant to what I'm going to talk today. Yep, okay. So, the title of my talk today is How Blockchain Helps Crypto Protocols. But when I say this title, people make faces because people are more familiar with this question, how crypto helps blockchain. And this is a very easy question to answer because we have public key elliptic curve crypto system, digital signatures, multi-signatures, aggregated signatures, hash functions, hash chains, Merkle trees, zero-knowledge proofs, proof of knowledge, multi-party computation, ring signatures, blind signatures, and many more. This morning, we heard about additive homomorphic encryptions, which also helps privacy and verifiability of data on the blockchain. So, this is an easy question, and now I'm going to move on to the difficult question, which is how blockchain helps crypto protocols or cryptographic protocols. Before I start answering this question, I'd like to explain what cryptographic protocols is. It's not encryption protocol like SSL or TLS. SSL or TLS, it's about a protocol that does the setup for encryptions. So cryptographic protocols is something different. Okay, so I want to see here, show of hands, who is not familiar with cryptographic protocols. Well, it's hard to explain, but it's a group of technologies that allows to achieve special goals of the protocols using cryptography. So what's this special goal? A typical example is called Millionaires Problem. And we have a goal for Alice and Bob here is for some reason, they want to find out which of them have larger amount in their wallet without disclosing what exactly they have. So this is called Millionaires Problem, and back in 1980s, I think, they found a very nice protocol. If you exchange a lot of bits in a cryptographic way, they can read how much they exactly have. So this is an example of classical cryptographic protocols. Let's go on to a second example, which is flipping a fair coin. We have here Alice and Bob again, and while they are apart, they want to agree on a single coin flip. And it must be fair, and no one is cheating. So we also have these cryptographic protocols for flipping coin, and moreover, it doesn't have to be only Alice and Bob. We can have more parties engaged remotely, and still they agree on a fair coin flip outcome. Isn't that wonderful? So the last example is voting. I know next week is going to be very exciting for the US, and we also heard from Brian in the previous talk that using cryptography, we can tally the votes and we can verify the votes. We can verify the correctness of the tally without disclosing who voted for what. Isn't that great that the vote you casted, you can verify that is indeed counted in the announcement on the newspaper next day? You want to make sure that your vote has been counted, and cryptographic protocols allows you to publicly verify that all the votes are counted and the tally is correct. Okay, so that's about what I'm excited about cryptographic protocols, but as you see in this picture, I think there is a big gap between these theoretical cryptographic protocols and the life we now live in, the real life. I think we can think of many reasons why there is a gap. Maybe the protocols are too theoretical, too ideal. Nobody wants that security or that fairness, or maybe too complicated, and therefore maybe people are not interested in implementing these cryptographic protocols. So now the question I have today is, how does blockchain help this situation? And they will take away the gap, and this blockchain will bring down these cryptographic protocols, technology, and all these results of research down to earth so everybody can enjoy its fruits from the research. Okay, so I will now go on to some of the examples of how we can use blockchain and incorporate it in implementing secure cryptographic protocols. One example is the notion of public bulletin board. Cryptographers had this notion from a long time ago that if we could have a deal public bulletin board, many cryptographic protocols can be made much simpler and efficient. But today, to my knowledge, we didn't know how to properly implement a public bulletin board. So what we do in the papers, we assume if there is a public bulletin board, then we can construct such and such protocol to make it secure, and we prove it that's secure, without knowing how we can fulfill that statement of having a public bulletin board. So what I mean by a secure public bulletin board is that anyone can write into this bulletin board, and if you once wrote it, you cannot change it. It's immutable. And we can see who wrote that message, and that everyone can see the content of the bulletin board. You see, this is very similar to what blockchain brings. And if the blockchain technology brings us ideal public bulletin board, that's how they can help cryptographic protocols. Okay, the second question, the second issue that they can solve is that most cryptographic protocols are designed assuming any message reaches to the other party. But here you see angry Alice says, I sent the message to Bob, but Bob ignored it. And what does Bob say? Alice never sent me a message. So this kind of dispute, Ryan, you had this thing, right? What did you say in your? It was dispute solving? No. Okay, sorry, I got it wrong. Okay. Anyway, so it was here. Okay, sorry. So this kind of message, this kind of dispute, it's something that we cannot solve from the outside. In Japan, we have this terminology saying water spraying argument, mizukakeron, saying that you can't decide which one is saying the truth. And sometimes in cryptographic protocols, we try to avoid this situation by issuing receipt. That if Bob received some message, he's going to sign it and claim that he received it. So Alice can use the receipt for later claiming what the situation. But this is not really a real-world solution, because if Alice couldn't get the receipt, he would blame it on Bob that Bob did not issue her a receipt. And what Bob would say can be two things: that Alice never sent a message for him to sign, or he would claim he sent the message, but Alice is claiming she didn't receive it. So these kind of disputes is something, again, this public bulletin board blockchain can help us. Okay, and there's more on the implementation. So most cryptographic protocols requires many assumptions. Having a public bulletin board is an example of such an assumptions, but they are more realistic assumptions and something we need to agree before protocols, such as semantics. If I want to vote for yes, am I putting 0 or 1 as a vote value? Sometimes people use URLs to show what does this semantics would mean. But with current technology of web servers, I'm really scared of this, because I know those web servers can be personalized. So if I ask for this configuration XML, the person might reply different answers to different people, and you cannot verify how the server responded to the other person. So having a common setup, it's something very hard in real life. And also, we need to agree on security parameters. If these settings are different, it's not that protocols would not be established, but moreover, the person who's engaging in this protocol with different settings might suffer from security breaches. So that's something that's very scared of. And also, someone's public key is something we. This was the point I wanted to come to, Ryan, is about how can we know which software is trustworthy. When you bootstrap the cryptographic protocols, you need to rely on the software that's running for you. Okay, so I'd like to summarize my talk. It's how does blockchain help crypto protocols? It's first, as a public bulletin board, to guarantee the delivery of the messages, and for sharing of the predetermined values and sharing of correct, secure programs on top of making the protocols efficient. And besides these technological help, I think socially, blockchain really helped these crypto protocols because they reduce this emotional resistance in using public key cryptography. When I talk to my customers, maybe even 2 years ago, they would hesitate to use public key systems because they're afraid of, oh, I have to use PKI. I know it's very complicated and it's troublesome, and that's the last thing they want to use. They want to use the PKIs. So these 3-letter words really kept me away from implementing something with public keys. And also, the rise of blockchain raised more interest in transparency and fairness. Long time ago, when I had these lottery systems, they said, oh, servers are fine, they're just trustworthy, you don't have to worry, and we don't have to use these cryptographic protocols. But I think now people are starting to realize servers are not always reliable. And because blockchain is a new technology, we don't have to worry about working with legacy systems. And that concludes my talk.
Thank you, Kazue. Please stay on stage. You're not going anywhere.
Okay.
We've got your public key and your private key, and we're excited to have you on a panel. And we're going to get you on a panel here with the likes of Elizabeth and Ryan. So this is a lineup. Is this all right? Or did you? Okay. Great. And we're going to have our moderator, Adam Levine, back from before lunch. So we look forward to more fabulous conversations, sort of digesting all the things that have been discussed before you today. So let's assemble these fabulous panelists and have at it.
Hey, check. Is this thing on? Okay, there we go.
Hi, Elizabeth. How are you?
Yes, and oh my gosh, you know what? I did not prepare the audience appropriately for this panel. I would like to apologize. There is a fourth panelist. Her name is Lily Liu. She is the CEO of 21. CFO of 21.
Correct.
So maybe you can allude a little bit to tell us, just give us a moment about 21 here.
Sure. So 21, we're in the Bitcoin space, digital currency space, and what we are most excited about is the prospect for digital currency sort of opening up new economies on the internet. And so the way we sort of think about that is on the internet, right? So the core transaction value is, let's say, on the order of 1 cent, right? The physical world is on the order of $1. But what we have today is sort of the economies on the internet are being monetized using the currency with a little bit mismatch for transaction size, right? So essentially what you have like the sort of massive liquidity trap and also price floor on the ability to sort of do native micropayments on the internet. And our vision is about opening that up and enabling sort of native micropayments on the internet. And with that, sort of we talk about eventually creating a machine payable web where machines can autonomously interact with one another, trade resources. And I think that's sort of similar to the vision that you were talking about with Blockstack, where you can have decentralized applications and sort of use Bitcoin or currency as a medium for interchanging resources, right? So that's a little bit about our vision.
Thank you.
Good company.
Yeah.
Great, thank you.
Sounds right in line. So this is the kind of scaling these blockchain applications and blockchains themselves topic. The thing that nobody wants to talk about is how we scale Bitcoin technically, or how we scale the big blockchains technically. And it's become kind of a thing where a year and a half ago when I would talk about this, everybody wanted to talk about it. And over the last year and a half, the enthusiasm has just been beaten out of people. So today we're going to talk about that a little bit, but we're also going to talk about the usability side, the use case side, the why does this matter to people side, because that, from my perspective, is the part that's been missing for a very long time. We have some great people up here to talk about exactly this issue. So kind of before we get into the specifics, let's talk about each of your specifics. When you think about scaling these types of things, what is the part of scaling that you're thinking about? Is it the technical side? Is it the application side? And where do you fit in that spectrum?
Well, I can start. What I think is very important is for a lot of people to get just a little bit of digital currency, or Bitcoin, right, in this case. And the reason why that is Bitcoin broadly has been down to 20%, sort of the Bitcoin, and you don't sort of have these closed loop economies where Bitcoin can be exchanged for something like a digital good or service, which is useful to you other than just sort of speculation. And if someone can get even a few dollars of Bitcoin, right, there's a lot of digital goods and services you can buy with that, right? And so once you start to sort of build up this sort of two-sided marketplace, if you will, for the uses and also supply of digital currency, then that's something that I think will start to onboard ways.
Real quick, when you say that people need to get a little bit of a cryptocurrency, do you mean that they need a little bit of it so they can use it in existing systems now, or so they have it later when a system comes along that they actually want to use?
And so they're sort of the supply of potential goods and services there, but you don't really have enough people who have that sort of native digital currency that allows them to sort of seamlessly and have a very good experience in buying and transacting in those goods and services. And so, like anything, as you're trying to build an economy, you need buyers and sellers. And so a lot of people are doing really interesting work in this area of sort of creating the supply of those goods and services, and you need to start to build up more users who can pay for them.
Makes sense. Thank you. Ryan?
Well, when I think about scaling, I mean, I think the first thing I think of is scaling demand on the consumer side. I don't think Bitcoin and technologies have people. I think it has a bit of a reputation problem and a bit of there's a pretty large usability problem, and there's a gap between like, okay, that's interesting, I heard it on the news, and actually translating to let me actually download an application and use it, whether it be like a Bitcoin wallet or an application that uses Bitcoin or uses some type of blockchain technology. So I think that's really important, and we need to significantly improve our software so that it is more usable, so that it actually solves real problems, like the full end-to-end user experience that solves real problems for people. I think we're still a large way away from that, and part of that's just because it's so much more complicated to build applications in this way. So there's a lot more challenges. Yeah. And I was going to say also about scaling the blockchains technically, and then also scaling the teams that are actually contributing software. So for example, having more core developers.
As a company, we're building an implementation of the Lightning Network protocol. So we recently had early October, and many of the major developers of the Lightning community came together to agree on an initial spec for a protocol, which is really exciting when it comes to interoperability. One thing I care a lot about is I believe in Lightning as a solution to scalability. I think sometimes people want like one solution only, and I'm all for discussing others. But people need with those types of solutions. So there are a variety of implementations that are out there of Lightning right now. The goal, as mentioned earlier, is to enable instant, high-volume, extremely low-fee transactions on the Bitcoin and of applications. You talked about marketplace, things like that. And then the second point, and this builds upon what Ryan mentioned, is I care deeply about usability and user experience. And let's face it, it's not easy when you're dealing with this technology. For example, sending email over PGP. Ask some MIT undergrads. There were studies where it took them, CS undergrads, like I think upwards of an hour to figure out how to send an email with PGP, right? So, we have a long way to go, but I think Lightning also provides us an opportunity to rethink some of the ways in which we can kind of construct the user experience to make it easier to abstract a lot of the complexity from the user, so the user can just pay, say, in a marketplace, or pay every time she visits an article online and not have to do
to secure the life much more greatly. So how to use blockchain in a more secure and fair and equity way is something to scale the blockchain.
So, thank you. So, I mean, on the technical side, let's just kind of jump right into that. I didn't actually hear anything here that was really about the technical. This was almost entirely about use cases. So, you've got a solution in Lightning. There are other solutions out there. There's side chains. There's the idea. I mean, there's even things like people look at speaking. So, is it all of these things? Are there any things out there that people are thinking about from a technical standpoint that you just don't think are going to work? Or is it like Andrea says, it's just all of the things all of the time, and it'll just work itself out with time? Why don't we start with you?
I think we are trying, like the privacy issues. We want verifiability of the chains, but also we want privacy. So that kind of thing. Well, I'm very optimistic that the researchers will come with a better solutions, and after time will come with good solutions.
So on one of the points you mentioned on the splitting of a chain, creation of two coins and how that doubles capacity, I do not support that for the Bitcoin chain. I think there would be really dangerous consequences from a chain splitting. There were all sorts of replay attacks where certain kind of exchanges or hosted wallets did not prepare for them, and then the funds were stolen. There's all sorts of talk about a bad user experience, confusion that could come along with a blockchain splitting like that. And let's face it, there are many more users of the Bitcoin blockchain than daily users of the Ethereum chain. That's not to insult Ethereum, they're not necessarily going to understand, why they just can't send their money anymore if there are two chains, or how they could possibly get attacked. So that is not a solution that I personally support. But that said, I'm supportive of exploring ways to scale. For example, you mentioned sidechains. I think those are a really interesting means of issuing assets that then are connected back to the Bitcoin blockchain. And with technologies like Lightning, you can also do cross-chain or cross-sidechain swaps that will still be tied to the Bitcoin blockchain via the sidechain technology. So to me, the answer to scaling is not one singular solution, but continuing to research, continuing to build out great technology. There will be fights. We've had a lot of fights in the Bitcoin community, and some things won't work. And we should proceed with, a degree of caution and security, but we should also continue researching and trying things.
So I see the blockchain that one uses as the primary feature that it provides is this log of transactions, right? Or a sequence of data that is impregnable, that cannot be altered, and that was produced by a network, right? So it's really this unalterable history. It's kind of like the fossil record, right? So the primary, that's the primary thing that it provides. And then you can just say, like, there's just raw data that has been validated in sequence, and then there's contextual information on top of that, like signatures and something that attributes value to outputs in Bitcoin. But it's important that we start with that and then build off from that. So I think, so the level of resiliency that the data has to change is extremely important. And so we don't want to do anything that scales the blockchain capacity that could compromise the indisputability of the truth that the chain provides. And so I think, first and foremost, we should think about the fact that there's a lower layer that needs to be absolutely indisputable and is very, very, very hard for a single party or a group that can collude to be able to co-opt it. And so second layer scaling is extremely important in my view. Of course, at some point I'm sure we will have to do some kind of block sizes increases. But I think the focus on layer 2 solutions to scaling is the right way to go. Of course, Lightning is the most notable one and is extremely important. And one thing that we focus on specifically is with scaling our types of transactions during public key for where you can link to cloud storage. We do not put, for example, IP addresses and all this information in the blockchain. We just hash a file, put the hash in the blockchain, and then distribute all the other data on a peer-to-peer network.
So you're using the Bitcoin. So to be clear, does your technology have its own blockchain, or are you just using a peer-to-peer network in conjunction?
So it uses can start a new network on Zcash. But the large network that operates on Bitcoin, the domain names, the public keys, and the hashes of zone files, which contain the routing information like IP addresses, that's stored in the blockchain, and then the peer-to-peer network has like additional.
Yeah. And then just for my own personal edification, because I'm actually genuinely curious about using your technology, actually, are you storing multiple hashes into the, are you compiling things down into a single hash and storing one hash that represents maybe 1,000 entries in your system, or is it each one unique?
So not yet. That's something that, aggregation is something that we want to be able to support in the future, but each individual, like let's say you purchase a domain name on the system, you would then send your own transaction with your own name and hash individually.
Right.
So there's no aggregation as of yet. but you could do that.
So now that seems like a kind of characteristic of a completely decentralized system where each individual participant is making their own entries, and therefore you can't kind of combine them together. So
yes.
that's a kind of thing that I'm working on similar things to that, and there are real scaling implications to doing that on Bitcoin, because as you grow, that means you're hashing linearly more into the blockchain.
Yeah.
So your end goal there is, so you're using this as a temporary stopgap, and then you'll be moving to kind of combining these. Or sorry, this might be going too deep.
That's one of many different solutions. I mean, like, the Bitcoin network can handle about 100 million transactions per year. Each transaction, like every name can be managed with like one, you can really get a name and manage it with a minimum of like 4 transactions. So you can do things like aggregation, you can do things like using subdomains, so maybe you don't need to have a single domain, so you can actually scale it in many different ways. Thank
you for that explanation.
Yeah,
please.
From our perspective, what we eventually want to get to is a public blockchain, right? If we just talk about sort of what we want that public blockchain to be capable of, many years from now, right? So Visa, for example, what clears about 20,000 transactions every second, right? And arguably in the digital world, the velocity and the volume of potential transactions you want to carry is much larger than that, right? They're much smaller, but there are many more of them, and they move instantaneously. And so in order to build a network that can handle that kind of capacity, that's really what we want to get to. And sort of how we actually get there, I guess there are several options for whether you scale on-chain, whether you scale off-chain, whether you choose to adopt a different proof of work or a different proof of work concept. Those are all options. But I think ultimately you'll probably have to have a combination of those, right? Bitcoin is at $10 billion, the most adopted digital currency, but if you think about $10 billion versus the amount of, let's say, USD or even the smallest fiat currency in circulation out there, it's still really a drop in the bucket in terms of economic activity. So Bitcoin is very relevant right now, but MySpace was very relevant at one point as well, before it became pretty irrelevant. And so I think that technology moves very quickly, and I certainly hope that we sort of figure out a combination of on-off, proof of work, whatever sort of combination of technologies that allow us to eventually achieve that level of infrastructure and support.
So let me connect 2 dots that I've heard here. One is blockchain agnosticism, basically, which is that the blockchain has a utility, and perhaps we're talking about Bitcoin now because it's the de facto one, but that's not like a long-term endorsement. That's a recognition of kind of reality as it is. Is that about right? You don't have to answer individually. Just like, anybody disagree with that?
Yeah.
Point of clarification: I believe in Bitcoin as I'm not going to guarantee it is 100% going to using. 50,
well, but yeah, but it's the functionality here at the core. And then the other thing that comes to mind for me, and this leads us into kind of our next topic of conversation, is that for as much as I thought it would be, and as much as it was for me, the money use case of Bitcoin, the money use case of cryptocurrency, and the thing where it's ages better, it's obviously so much better in so many different ways, and yet nobody but us cares. So I mean, is that also why perhaps why we're so interested, frankly, in these non-technical solutions, because they present the opportunity, because we think that scaling is going to figure itself out one way or the other, but the other stuff, the use cases, the reasons why people actually want to use this that aren't just it's better money, those are things that still are kind of in the very nascent stages. Anybody disagree with that? Okay, cool. Then we'll move on to the next question, which is...
Can I make one quick comment? So, as you guys know, I used to teach about the history of the internet, and right now I think we're in the early 90s of blockchains, right? And everyone, I think, wants it to be, more like 2010 or something. And I think we're impatient, and it's going to take time. Tim Berners-Lee created the World Wide Web in the early 90s, and it initially was really basic, and then now we have like a very different web than we did back then. So to me, it's going to take time, And it's easy to say, oh, there'll be no use cases, or nobody's using it. But I do believe in due time, give us a few years, we'll get to 2000, and then hopefully 2010, and then eventually we'll get to today.
Sure, yeah, that makes sense to me. So yeah, I mean, to this point, again, a lot of the conversation that we've had and that I've had with a lot of people over the last couple of years has been about the fact that Bitcoin was better money, or that cryptocurrency is better money. But in the last 2 years, I've personally gone down things that have nothing to do with money and are basically what I call the non-monetary uses of cryptocurrency and the non-currency uses of cryptocurrency. So, anyways, yeah, what kind of interesting use cases do you see coming down the path, and how far away from something that my my mom would want to use and actually find useful and not just innovative? I mean, how far out from something like that are we?
I don't think we're terribly far off. We're working on something which we'll be launching in probably a couple of months that I think people will find pretty interesting. But I think, incrementally, so the idea is you always want to potentially move, you sort of want to expand into an adjacent space to help people and do that where having sort of a very liquid and very instant payout system actually makes certain types of internet experiences incrementally better. Advantage of term.
I think there's one aspect of the blockchain that's really interesting to think about, which is that there is, I was talking about before how at its core, the blockchain is this indisputable log, right? And there's limited space in it. And in order to put data, or write data, issue a transaction in this chain, you need to spend some Bitcoin, right? So you could say okay, well, there's the point of Bitcoin is to transact financially, but what if you can think about it a different way. What if the interesting thing about Bitcoin was actually the fact that there's this spam protection token to get access to this indisputable log that is secured by a set of computers around the world. And so then what's interesting there is, well, the transaction fee itself is the part that people are coming for. And you have many, many different developers, each working on their own applications, that are paying to play. They are paying a toll to operate their application and buy a percentage of this fixed space that anchors their application. And so we've kind of seen Ethereum kind of pushing that angle a little bit, and before that we saw on Bitcoin with a lot of the layer 2 protocols. But I think that's extremely interesting, because then when you think about that, that's okay, well, the blockchain itself and Bitcoin, they are very useful as the spam protection token for application developers. So maybe the main customer is developers for Bitcoin. And we're seeing it's actually very, very useful for these kinds of developers. Maybe that's the main customer, and then the developers themselves build these decentralized applications where their customers are end users. I think that's a potential future where actually we see non-financial applications overtaking financial applications. It's possible, right? And
so do you think they're building on layer 1 or layer 2 or both?
I see the application developers building on layer 2 and using the transactions on layer 1 to as this, this
to cement it. You would actually need to use layer 2, because layer 1 you can't interface with people who don't have cryptocurrency, whereas layer 2 you can.
Yeah, exactly. So I think that's an interesting thing to think about. And then when you think of it that way, then there's this whole new world that is oh, okay, well, then maybe this isn't just about.
That makes sense. Thank you for that. Elizabeth?
Let's move on. I have a lot to say, but I want to get to questions. So.
Okay. Well, no, I mean, you're next to answer, actually.
Oh, yeah.
But okay, then feel free.
So I just want to add to Ryan's comment on having small cryptocurrency to pay for the apps and pay for services. Current world, we are having these Facebook apps and Google apps because they use it because it's free, and there is no way to pay for a small amount of money for small service I want to get. So that's why people want to use free apps. But if we have a way to pay small money for the small services, which I really want for, then it's going to change the world, and people who are serving fair services will get a way to earn money and not the monopoly where big companies have free apps and collecting everybody. So that would change the world.
Gotcha. Thank you very much. So we will take questions from the audience. I have one more question. We'll start with you, Kazue. Could you please talk about, so you went over a bunch of non-monetary use cases that I thought were very interesting, that were less like consumer use cases and more about hard problems in cryptography that so far there haven't been solutions to, and how blockchains kind of present solutions to those. Are any of those compelling? Are any of those, I mean, like, it seems like there's a major switching cost with something like a voting system. I mean, like, it just seems like that's a long path to get from here to there. Even if we can do it now, it's more about adoption and normalization of these technologies than anything else.
Exactly, right. So I'm still struggling to come these technology down to earth, to real life, and I'm just hoping.
If I could maybe add on that.
Right.
So the way that we think about it is that there are a few common things that you want to do on the blockchain to enable decentralized applications, and then most of the logic and the work isn't actually even done on layer 2 on the blockchain. It's done completely outside the blockchain, right? And it's just data. You're just working with data like a normal application. If you build a decentralized Twitter, almost everything is with like signing messages and transmitting data and processing, building the feed and all this other stuff, right? The common components that you want to use that might require the blockchain, you would use an identity system that's built on the blockchain, a domain name system that's built on the blockchain, right? And so that's what we provide with Blockstack Core. So you can have, for example, you can have each user have their own username that they completely own, right? That can't be taken away from a company, right? You can have them have their own public key, right? And you can have services encrypt you can basically have client-side certificates and have secure channels between all of the peers in a system. And so all those things are provided by common services like naming, identity, authentication, and storage that can be provided by something like Blockstack. And then the applications, they don't have to worry about any of that stuff, and they just build it like a normal application and just plug into APIs. So I see like what we're trying to do, and I see some other projects that are trying to do the same thing, is provide these common components, and when you provide them and they have a good enough user experience, which we are still a good ways away from, but once we get there, then you will see an explosion in these applications. It takes a little time to get to that point where that experience is brilliant, just like when you saw with the early versions of the iPhone.
Two quick comments. First, while I think non-financial uses are interesting, I still believe in the financial use cases. There are a lot of potential there, as discussed with Lightning. For example, we recently hired an intern who is based in Russia, and apparently his bank will take away his money if they don't have proof that it was received in a certain way. And I was saying, like, this is why Bitcoin exists. So he will be hopefully paid in Bitcoin. And second, so often I wake up and I actually feel like I'm living in a sci-fi novel. I don't know about you guys, but this world is kind of ever-changing, and all sorts of crazy stuff happens every day. So at least it never gets boring. Let's just put it that way.
I agree. That's definitely true. Any questions from the audience, or are we back to me? Okay, cool. So what about, if somebody has a question, please raise your hand and someone will bring you a microphone. But in the interim, let's talk about user interface and user experience, because that continues to be, as we've discussed, kind of one of the hard problems in Bitcoin. And then kind of the other one that I would say, which is just the elephant in the room, is that it's still really difficult to buy cryptocurrency with anything that's not already cryptocurrency. And I mean, like, between those two things, it's hard to use in the application. Local Bitcoins? Yeah, exactly. Local Bitcoins. Why not go to a coffee shop and hope you don't get mugged?
Exactly.
I mean, like, it works most of the time.
Meet at a police station.
Right, exactly. Yeah. So I mean, but seriously, like, we're talking about, how to actually scale this thing. It seems like user experience is one of the times, and just basically extend whatever the person is buying in advance, and then to kind of follow up on the blockchain after the fact. And this allows you to do kind of instant fulfillment of whatever the heck is going on, while at the same time you don't
insure it.
Pardon?
Do you insure?
No, it's not insured. It's not actually, again, like you do. It's provided via API. So people who want this sort of thing use the API, and the API is basically the blockchain information appended with temporary ownership information that bridges the gap between these things. So that's one of the things that
You mean like a zero-conf API? API?
Yes.
Okay.
Yeah, but in the work that I do with tokens, it's a little different because the access can be provided in advance, since it's not necessary. So one of the most common use cases for Bitcoin is the transactional use case, which is the ability to send a Bitcoin or any sort of cryptocurrency from one user on the network to another user on the network. But there's another use case that isn't really talked about yet called token-controlled access, that I'll toot my own horn on for a little bit for a second here, that basically is if a user can cryptographically prove that they own a particular Bitcoin address, then any tokens contained within that Bitcoin address can be associated with that username within a given system, whether it's an application or a website or whatever. And so 2 years ago, we started using this as a way to create private access forums, where a person would get a token, and then that would give them access to a forum, and anybody could create a forum, and anybody could create their own token. So anyways, you can provide the access part in advance via the API, and then follow up with the transferable portion after the payment has actually settled. So that was a long tangent. Back to UX. So what other things, like what are you guys working on to solve the UX problem? What do you think is a hard problem with it, or something that people haven't done right that you have an idea to do better?
I think that when you receive Bitcoin, people are not used to what is a unit, what is like, people don't have an instinctual idea of how much one Bitcoin is worth to them, right? When people think one, they don't think $750, right? They don't think, oh, I could buy a phone with this, they think one, right? So I think that helping people translate that into whatever their fiat currency is makes it a lot more intuitive for people. And so talking about, I think Bitcoin, if you sort of abstract it away and translate it in terms that people are already familiar with, that's the easiest thing. Bitcoin addresses are not, people compare them to email addresses, but they're really not. I mean, they're a string of random characters, right? It's very not intuitive. It's hard to memorize. So
abstracting away the addresses and abstracting away the value transfer, right? The place where you have to mentally be like, all right, this many dollars equals this many Bitcoin, and just instead presenting it the other way.
Yeah, so if you earn a little bit of Bitcoin, you say you earned $1 worth of Bitcoin rather than saying you earned 0.000, whatever Bitcoin, or Satoshis, who knows what a Satoshi is, right? Outside of Bitcoin, so.
Yeah, I completely agree with denominating amounts in USD or whatever local currency instead of Bitcoin. I also agree with respect to obfuscating out addresses. Users shouldn't even know that those exist, just like users do not know that IP addresses exist. And that's one of the things like we're actually working on with Blockstack, because we provide these memorable names for people that can tie them to information, all kinds of information. And so if you want a Venmo-like experience where you just pay to someone in your contact book, but you want it to be decentralized, you can use Blockstack, again, to tie the username. You can just pay to a username instead of having to pay to an address. You can pay to a username that's attached to, for example, a hierarchical wallet, right? And then another thing I think that's very important is actually probably the most important thing is private key management, which you look at all these applications, it's like the most difficult and most frustrating part is the keys themselves. And no one has cracked it. It's such a disaster. Early, we actually worked on this application called, you might be aware of it, it's called onename.com, and we had this early solution years ago where users would put in their password, and they'd pick a password, and then they would download a file to their Dropbox or local drive, and then the file would be their backup file that if they forgot their password, it would allow them to recover their key, which is like a better experience than writing down the 12 words that you might have used in a lot of wallets. And then we're also working on a more advanced version of this for our new product.
Quick question for you guys. How do you deal with the fact that the balance will change from the user standpoint? That's something that I've wondered as well. And then they're like, wait, I now have double the money.
Yeah,
or half.
Or half, right?
You can show both.
Yeah.
I mean,
Yeah, you can show both. I mean, it's like holding pounds over the last month or so, right? Happens in the fiat world as well.
So I was going to say that because this is many people from Japan is participating, it's very hard to beat the user interface of the NFC money. It's very widely used in Japan. So in Japan, using Bitcoin as a cryptocurrency, and this user interface, it's very hard to defeat. That's one that is being currently used.
That makes sense. Great. Well, thanks everybody, and that concludes this panel.
Thank you.
Thank you.
Thank you.